All right, let's get started. I forgot to plug in my webcam. Let's get started in a second. All right. Gosh, I thought all of this was already set up. My bad, guys. Cool. All right, so malware development time. That's fun, right? So today we are going to be doing all kinds of stuff. I skipped a stream yesterday, skipped another stream, or 2 streams maybe last week. Got sick and then got dental stuff that I had to get done. So that was no fun. Delayed us a little bit. But today we're going to be dealing with some fun stuff. We're going to build a C2 and we're going to do some more Rust stuff. We're going to start with the C2 work just because I think that'll kind of warm me up a little bit. So I'm going to get a box open real quick. Let's see. This one should work. And let me pop my screen over. Ooh, why is that flying around? There we go. So we want to drag this over. And oh man, that's a mess. There we go. Then we need to change our webcam over. Sorry, I thought all of this was fixed. Let's see. Oh, this is annoying. Alright, I promise this should be working soon. Just gotta get rid of that. Throw a new source on there. There we go. Display caption needs to get shrunk down. I don't know why all of this stuff got messed up. I mean, it's all jacked up. I switched back to Streamlabs because they've got all kinds of like things that are just in general better. But apparently, lots of it was broken. All right, so we're gonna start working on the C2. That's first and foremost focus for this stream. I know lots of people are here for Rust. We will get to the Rust, I promise. But first we're going to start on the C2. And we are, let's see, about like 30 minutes into the recording, it feels like. Let's see, how far are we into the recording? Right, 5:52. So 5:52 into the recording, we actually get started. So, first off, let's start a project for this. I might already have one. No, I don't. So, we're going to make a directory, C2. I don't have any of my Vim stuff over here, which kind of sucks. I've started using Vim for my text editor, which I'm sure people are going to give me shit for because I don't know it that well. Let's do pip. Do we have Python? Yep, we do. So pip3 install unicorn fast API. I think request is default, but we'll see. I think that's all we need right now. Okay, sudo apt install python 3 pip. It's held up by process. That's interesting. All right, well, we'll just kill that real quick. 26415. Right, now let's try. Okay, apparently we did not successfully kill that. We might have to reboot this real quick. And now we're not able to reboot. Very cool. We'll just full kill it. We might be starting on Rust, I guess. I don't really know what's going on there. All right, so let's see if we can pop this back open. We may have to get rid of the save state now that I think about it. My dogs are fighting over food in the background, if you can hear that. All right, now let's see if we can do it. We're gonna need pip. We're also gonna need to remember our password. There we go, that should work now. All right, we got it. So, now we need to install all of the dependencies for our C2, which is boring, obviously, but necessary, also obviously. So we're going to build a React front end with a fast API backend. If you haven't used fast API before, I've got a video for it on my channel. Let me actually, I'll post that in chat real quick. I've got a video about it on my channel. It's significantly better than Flask. I like it a lot. Here's an okay video on it that I did. You can watch it there. And I'm playing it in the background like I've never done this before. So you can watch it here. That's just kind of like an overview on how to build stuff with Fast API. But if you've built stuff with Flask before, it's fairly similar. Let's see. Got rid of our directory C2. So let's create. We're going to make dir backend, front end, and we're going to cd to the backend. We are going to touch api.py, and we're going to install. Let's see, we need Unicorn, fast API. I think requests is a standard library, but we'll see. That should be all we need. JSON I know is a standard library. Let's see, do we have code? We do not. Sudo snap install code. So since I don't have my Vim set up, I'll be using code for the C2, and I figure people will probably complain less about me using VS Code, honestly. So I'll do it that way. Oh, I forgot to tell Mastodon that I'm live. Let's see. There we go. I'm on Mastodon, by the way, because Twitter is going to shit and it's only going to get worse. So if you are a fellow Mastodon user, there we go. And there we go. The Orange Man announced that he is running for president, so you know his ass is about to be right back on Twitter, and I just know that's gonna go badly. But we're not gonna get political in the first 15 minutes of the stream. There's just no point in that. So basically, we're going to set up our C2 to be React.js for the front ends, fast API for the back end, and we're not going to use a database, at least in the beginning. We might use one later on, but we're not going to use a database. We're going to just use JSON files because that's way easier. And why is this taking so long to download? Oh, that's annoying. So let's actually, while this is downloading, let's pop over and talk about Rust. So here's a new tab. So we've got our netlib directory, and here's our module for that. Oop. And we've got our main Rust file, and here's the module for that. So last we left off, we were talking about how to use the Windows API with Rust, which is quickly becoming interesting. It's its own crate, and crates are kind of how Rust handles libraries. So Rust has an awesome, basically package manager, like a crate manager, I guess you could call it. Called Cargo, and it's also how you run all of your code as well. So you can use Cargo basically to install the files necessary for the Windows API. So it's very similar to NPM. I believe it was intentionally made very similar to NPM. So we've got our main file open here. If you look, right here, basically this is us actually implementing our own crate that we've got, or our own library. So we've got a library crate, or a library file called netlib, and that is there. Very, very simple stuff here, nothing fun or anything interesting here. Basically just to kind of show off exactly how you use these separate files in Rust. It was more to teach myself how to do that, honestly. Let's see. And here's where we're actually using the Windows API code. So if we go ahead and run this somewhere, let me go ahead and exit out all of these, save a little bit of RAM. So as you can see, I already ran it once. Cargo run. We get our hello world file. It runs very, very quickly because I already had all of the other external crates downloaded. So it runs fairly quickly, and we get all of the run information here. Now we've got our guest here, and ooh, we don't want you on. Definitely not. I'll turn that off later. It very rarely catches anything, honestly. I haven't really had to deal with it much. It says it didn't find any threats. Even when I was writing malicious looking stuff, Windows Defender just did jack shit. So I don't really worry about it too much. All right. So we've got our desktop open here. We can pop over to our shared drive, make sure that we have access to Rusty Wolf. And here's our main.exe. If we wanted to, we could copy this over to our desktop, get rid of this main.exe, and run main.exe. Just prints out to screen. That's interesting. Did I paste it? Did I paste the correct one is the question. Let's pop over here. Let's see. It might actually be in Target. Yeah, let's CD over to Target. Yeah, we get rustywolf.exe at 8:12. That's not it. Maybe that was the right one, and it's not doing what I want it to do. That's perfectly possible. CD source. No, because that was last created on 11.8. I think you gotta run, I think it's just rust C. Or maybe it's just cargo build, I think. Rusty Wolf. So it built successfully. Change the target. Debug. Last built 11:15, so that's today, but at 8:12. That's weird. That's definitely not it. Main.exe built at 7:11. That's definitely not it. Getting my Linux commands mixed up with my Windows commands. It's always fun. All right, so let's just use rust C. Rust C, main.rs, -o, main.exe. That didn't work. I think we are going to have to use cargo. Let's see. Compile the current package. It should be it. Can we give it an output? Cargo build. Offline. Exclude, verbose, all. Frozen, keep going. Lib, locked, bin. That's not what we need. Build all binaries. Build only the specified file. Test bench, benches, all targets. Release might be it. Target directory. Outdir. Build plan unigraph. Let's just do cargo build. Let's see, dir source. So it didn't create a new main. Dir. Just do dir target. Debug, dir. Last built at 8:12. Are these inaccurate? Let's try rustywolf.exe. So if we go back and change something, these might be inaccurate. Let's just add an exclamation mark. Now we don't, damn it, I've exited Vim. That's annoying. And Vim dot. All right, so let's build it again. And cargo build. To the previous error. How do we do that? Let's see. Cannot find. Oh, I probably fat fingered something. Let's see. This. Let's check netlib first. Netlib. Yep, I sure did. There we go. Now let's build. All right, so we've got to build. What we should get here, target, debug, Rusty Wolf, should have an x.exe, Rusty Wolf.exe. All right, so these timestamps are wrong. Like dead wrong. Oh, that one's right. Huh. It was wrong before though. Whatever, dude. So now we're successfully building. It only took us like most of the stream thus far. So let's go back to our API code. Let's see. Oh, that wasn't what I wanted to do. Main.rs. So here's where we're importing message box A right here. Here's where we're importing some like Windows kind of values. So MB OK, meaning like mouse button OK, MB icon information. Can't remember what that does actually. Let's see, we can actually look that up. Let's see if VS Code is finished downloading finally. Should have. We'll upgrade that later. Oh my gosh, it's still going at like dead slow per second. Ah, that's probably because I'm streaming, I would assume. Whatever. Might be a bit until we get to actually writing the C2 now, which is annoying. That part I'm actually fairly excited about. Writing C2s is fun. Okay. So what were we doing? We were looking up. Let's open up a new one of these. We were looking up MB OK Windows API. So here's just a message box function. So what we're looking at is the last input right here, which would be the uType. Contents and behavior of the dialog box. Okay, so this is just telling us what kind of box it is. Message box contains one push button. Okay, this is the default. And then we've got what is icon information or ICO information. Icon information. There we go. To display an icon in the message box, specify one of the following values. An icon consisting of a lowercase I and a circle appears in the message box. So we can see that. We pop on over to here. Run it again. Okay, so it's this little icon right here. Cool. So let's try it on our actual quote-unquote victim machine, and let's make sure that it actually runs. So we're actually looking for Rusty Wolf, targets, debug, rustywolf.exe. I'm almost certain that we had the wrong file last time, and that's why it didn't work. So let's try rustywolf.exe. Cool. Okay, so it's working on our victim machine. That's what really matters. All right. So again, we are successfully running Windows API code with Rust, which doesn't seem like a big deal, but it's kind of neat. Now what we're going to do is slightly more boring, but also important, if I can find the right window. We're going to basically plan out how we're going to lay our code out, if that makes sense. Well, let's see if I can open Excalibur. I tried doing it before and it didn't work. Oh no, I gotta pay for it. Never mind. So here's how we're going to lay it out. I'll just do it in text. Control Q. We're going to go back and open up docs.md. So let's not worry about any of this stuff right now. So, plan for stream on 15 November. So we're going to build out a C2. Build out a C2. We are also, as part of that, simple API. We're going to have a simple API. We're going to have a simple JSON format for victim info. And we're going to have a very simple dashboard. Okay. We're also going to lay out the skeleton of our malware code. That part isn't fun necessarily, but it kind of allows us to plan things out a little bit better, so that we're not just jumping straight into things. Hi Valhalla, I'm starting to learn Rust. What do you like in Rust over C++? Let me show you. I'll show you exactly why I like Rust over C++. Let me pop open our main.rs. Okay, so if you look at this code, the best way for me to explain it is it's very simple. Like, you can see what all of these things do. This is a variable that holds a C string, which is just kind of like a special, cool type of string. And that string has the value hello world, and unwrap, it means something you don't necessarily have to worry about that much. Same thing here, yeet equals yeet, like, it's understandable. Now here is one area where Rust is like, I don't know, it's not necessarily unclear, but it's different. It's sad to see you convert the code to Rust. We are missing the C++ days. I know, and I might go back eventually. But right now, Rust is just so much easier, and it's so much more fun to write. So, be looking out for it, but don't hold your breath too much. So here is like the mechanism that they use for function calls in other modules. So this print netlib is from our netlib module, which is here, and we've got a public function that it exports here, and all it really does is like append things. It's nothing really fun or anything like that. But the main reason why I like Rust is it's just so much like clearer. Like, I can open up here. I'll give an example. Let's see. I'll open up some C code. Let's go to Wolf and open this up with VS Code. So we've got our C2 here. We've got our standalone. If we pop over to comms.cpp, like, look at this. Again, I'm an idiot when it comes to C, C++. I fully admit that. But there's no way you can tell me that C, C++ code, all of this nonsense. So basically here, you can see it. This is like basically a one-to-one example right here. This is how you call the message box function in C++. You've got a null value that's fairly unexplained, which I believe you also have in the Rust. Let's see, message box A. Yeah, so you've got null in message box A. You've got to pass the strings in a specific way as like pointers, but it's like clearer here. Okay, so looking at the code back to back, I might just be bitching, but C++ just, there's nothing that you can tell me that like would convince me that Rust isn't more clean looking and more understandable. And I don't know. I honestly, part of it is I got so burned out on writing in C++ that I needed a change. And when I found that change, I was like, oh, this is obviously better. And it may not be. Honestly, now that I'm looking at the code back to back, it's not that different. But I guess there's just something, for one thing that absolutely is 110% better in Rust compared to C++ is if I want to add a dependency in Rust, I just use cargo. It's literally as easy as using npm basically. It's the same thing almost. And I can install a dependency. Chase, I am writing in Rust. I'm comparing Rust to C++ and explaining why my newbie ass likes Rust significantly more. So Chase is in the Twitch chat. He knows Rust significantly better than I do. And he's probably going to show up and tell me all of the different things that are wrong. But I was basically explaining, for one thing, Rust has its own external dependency manager like npm, which automatically makes it significantly better than C, C++. To me, there's just nothing about C++ that looks as good as Rust or is as clean to write as Rust. I'm very new to Rust. I might find things that I hate about Rust, but as of right now, the code is significantly cleaner. It's way easier to deal with external dependencies like the Windows API or like a lot of the other libraries that people use. So to me, like it's also too, people are just using it more. Like, so if it's going to be the new thing that people are going to use more often, I want to learn it. It's also wicked fast. You can use it for web front ends if you want to export to WASM, and WASM is also wicked fast. So like there's just a ton of cool shit that you can do with Rust that you can't as easily do with C, C++. And C, C++, to be fair, is like a 40-year-old language, you know, so you can't blame it or anything. I'm not like just gonna shit on C, C++, but Rust is like, it's new, and they're doing a lot of like, it's significantly easier to write secure code with Rust because of the way they handle scoping. It creates some like weird errors that I still haven't gotten used to. But you know, like here, I have to explicitly state, hey, this is an unsafe call for whatever reason. I can't remember exactly why it's an unsafe call. But like all of your like memory unsafe code goes within an unsafe block. Like you're explicitly stating, I know I'm doing this wrong, basically. And the way they handle like, you know, memory safety and all of that with their scoping mechanisms is just better. Anyways, that was a long rant from somebody who doesn't know Rust well enough to like explain all this shit. But basically it's the new thing, and it's something that I wanted to learn. So that's why I'm learning it now. And I want to be as good as Chase at Rust someday. All right, so let's go back. Let's go back over to our docs. So we're going to lay out the skeleton of our malware code tonight. That's going to take a bit. And we're going to start playing around with network code. May not get to like a fully implemented network library tonight. That just sounds like it's going to take a while. But we'll at least start playing around with it. I'll do some research on it on stream, and we'll kind of chat. So let's look at notes. Notes for this stream. All right, and right. So let's see if we've got VS Code working yet. Oh my gosh, why is this taking so long? 150 kilobytes per second. I imagine that's either because I'm using a virtual machine and streaming, or just because I'm streaming. I don't really know, but this is like significantly slower than normal. Let's see if we can find a way around. Do I have a shared folder on here? Let's see. What's the Stunner? No. Files. Stunner, I think, is on Arch, right? Now I just remembered how much of a pain in the ass shared folders are on Ubuntu. Let's see. No, that's all of the stuff that I'm using for operating system stuff. Let's see. media. Nope, that's not it. I may not actually have any of that mounted. I don't really want to... I might just have to wait on this. All right, so we'll start with everything else first. Let's hop over and start building our skeleton code. So within our netlib, let's start with that. We want a... So we want a generic send over. Do we want to send over HTTP? Let's start with send over HTTP. And that's going to be pub function send message MSG. That's going to be a pointer to a string. And we are going to send back, we want to send back a map. Let's just say and str. We'll start with that. Let ret equal to string from. Eventually we will ret. All right, so that's going to be what we return. This is going to be a generic send message function. We're going to also have a pub function send ping. I'm not going to have any inputs to that, and that does it need to, yeah, it does need to return something. And string. For right now, we're just going to return strings. And this is going to format a ping message. Oop. And I forgot the keybind for redo on Vim because I am that new to it. Let's see. Vim redo. Control R. That's not what I'm wanting to do at all. There we go. All right. So we want to format the ping message, and then we want to send ping message, and then we want to get a response. Let's do ret equals string from. This is going to be our placeholder for now. Return. There's no return. Ret. Right. So we've got a generic send message. Let's do this. Just do send MSG ping. Don't know if that's going to be the right way to do it. If we need to do a pointer to that, let's see. Can't remember if Rust automatically handles that. Be nice if it did. Cargo build. Oh no, wrong directory. Cargo build. Did I write that? Probably didn't. Oh, that didn't work. Expected name, lifetime parameter. Uh-oh. Missing lifetime specifier. This function's return type contains a borrowed value. There's no value for it to be borrowed from. Consider using the static lifetime. Huh, don't understand what that means. That looks like something I haven't researched yet. We'll get there. All right. So, Rust lifetimes. There's something to research. Rust lifetimes. Let's look it up. Rust lifetimes explain. Pro tip, if you're learning literally anything, Google it as quickly as humanly possible. Try to figure it out through like the code that you're looking at, but like just don't worry about just going ahead and Googling it. Also, XYZ explained is your best friend. It's just like a very quick way to find fairly good blogs or YouTube videos or what have you. All right. X does not live long enough. Introducing lifetimes. Lifetimes are what Rust compiler uses to keep track of how long references are valid for. Checking references is one of the borrow checker's main responsibilities. Lifetimes help the borrow checker ensure that you never have invalid references. Lifetime annotations enable you to tell the borrow checker how long references are valid for. In many cases, the borrow checker can infer the correct lifetimes and take care of everything on its own, but it often needs you to help. This guide will go over the basics, blah, blah, blah. Before we go any further, just a short note on the notation of lifetimes. It's a bit difficult since lifetimes are annotated by a leading apostrophe followed by a variable name. Huh. When talking about generic lifetimes, we often use single lowercase letters starting from A, B, etc. However, there's nothing stopping you from using longer, more explanatory names. Let's see, the explanatory example. That's what we need. Let x, y equals, okay. This little piece of code has two distinct scopes. When the inner scope closes, y is dropped, meaning this is gone. Since this is declared within this scope right here, this part I do understand. So this right here creates a new scope. And with Rust, basically the memory is managed through scopes. So you allocate memory within a scope, and as soon as that scope is over, that memory is considered gone. So it's just deleted. You don't have to worry about it anymore. So right here with these brackets, you're creating a new scope. As soon as you leave this bracket, anything that's created within that scope is gone. So that's why this isn't going to work. Or x equals and y. Okay, so x is basically trying to keep y alive here, and that's not allowed. I think that's the problem. So basically, if you've got a variable that's going to fall out of scope, you can't just throw that variable into another variable that has a different scope. I think that's the issue. I could actually read, and that would help. This little piece of code has two distinct scopes. When the inner scope closes, so this scope right here, y is dropped. At that point, even if x is still available in the outer scope, here, the reference is invalid because the value it pointed to is dropped. Okay, so y dies here, basically. So since y is dead here, a pointer to y is now going to point to null memory. So you can't just throw a pointer to null memory into x. It's going to have a problem with that. That makes sense to me. That's one of the reasons why I like Rust. That's cool. It's a good way to handle this kind of stuff. Is Rust and C++ performance pretty similar? I think so. C++ is safer to write, and I think since most C++ programmers probably don't write C++ correctly or like handle cleaning up memory correctly, then you're probably going to have better performance with Rust. But that's more a guess than anything. Okay, the reference is invalid because the value it's pointed to is dropped. The value that x points to does not live long enough. So y does not live long enough to set an x. In lifetime jargon, we can say that the outer scope has the lifetime outer and the inner scope has the lifetime inner. Outer clearly outlives inner in this case. When inner ends, all values with that lifetime are invalidated. Okay. So let's hop back to our notes. Lifetime is a method of explaining how long a variable and its associated memory lives. Examples and common problems. Okay, so lifetime elision? Is that a word? Elision? The emission of a sound or syllable when speaking. That doesn't make sense. Deletion is the emission of one or more sounds in a word or phrase. Okay, when writing functions that accept references as arguments, the compiler can infer the correct lifetimes in many cases, saving you the trouble of writing them out by hand. When lifetime annotations are implicit, we call that lifetime elision. Okay, so we're leaving out the lifetime decision there. The compiler uses 3 rules to figure out whether lifetime annotations can be elided or not. The book section on lifetime elision talks about these rules in detail. The short form is that you can elide lifetime annotations and functions if one of the following is true. The function does not return a reference. There is exactly one reference input parameter. The function is a method taking and self or and mute self as the first parameter. Lifetimes are a tricky way. It's likely the wall of text will help you really understand how they will work. The best way to get a proper understanding is, of course, to play around with lifetimes yourself and solve problems. Returning references from functions. Okay, so this is what we need. You can't return a reference from a function without also passing in a reference. If you try, you'll find that the reference is invalid as soon as the function returns and your program won't compile. You can use the static lifetime, but that's probably not what you want. It's outside of the scope of this article, so let's forget about it now. So that didn't really... Okay, here it is. If your function takes exactly one reference parameter, then you'll be fine without annotations. All output references will be given the same lifetime as the input parameter. As such, this simple function will compile just fine, even if there are no explicit lifetime. Okay. So let's go back and look at our error right here. So it's got a problem with send ping because we're not passing in a reference. This function's return type contains a borrowed value, but there is no value for it to be borrowed from, considering using the static lifetime. So it basically doesn't have anything to like inherit the lifetime from. Basically, that's the problem that it's having. So we could pass in like a null string or like a null string pointer, I would think. But that doesn't seem like a graceful way to do it. We could also just get rid of the return value, because what this function is going to do is it's going to ping our C2, figure out whether or not the C2 is alive, and then return back. But we are interested in whether or not the C2 is alive, so we do kind of want a return value. We could just return a string, couldn't we? Let's see. Can I open up a new tab and not realize it? Why do you care if it's alive? Yeah, that's... I don't think I do. So let's pop open netlib. So let's just return a string here. And that should be fine, shouldn't it? Let's try that. And string found struct string. Okay. Consider borrowing here and res. Okay, so that's having an issue here. Am I tripping out? Okay, that's what we're looking for. Let's just do from SG. Right, see, the problem is we're literally just using placeholder values here, so we don't have anything like realistic to like borrow from. Size for values, okay, that's fair. So what it's complaining about here is it does not know how long message is going to be. So it can't properly like create this function and basically tell, okay, let me compile the way that I'm going to explain this. So string from takes an input string and will basically allocate memory in order to put that string on the heap. If we give it like a variable length or like a variable input, so if we just did this, basically this is saying, hey, we're going to pass an arbitrary like length string, which is fine, but not in the context of using string.from or string colon from. So I think instead we'll just do this and return a pointer to red. That should be fine. Right, so we got rid of one error there. Does not have a size known at compile time. Size for values of type string cannot be known at compilation time. Okay. So here it's having an issue because what it's returning could have any like length size. So the bar, I think that's the borrow checker that's having an issue with that, right? That's probably a piece of vocabulary that I'm using incorrectly. That we can fix pretty easily. So let's go back to send ping, and we're going to just return a string. So here, which one is it having a problem with? Send ping is still a problem. Both of them were. So that may have fixed it actually. Did not. Cannot return a reference to a local variable. Okay. That makes sense, and I don't know why I don't know why I thought it would work. So here, basically, we're trying to, again, this is something that's unique to Rust, and it's taking some getting used to. But right here, we're trying to return a pointer to an address that's going to go out of scope. And because the address is going to go out of scope, it's like gone. So you can't return like a pointer to an address that's going out of scope. So what we really want to do is just return the string. But for some reason, I think we couldn't do that. Everybody's getting a live look how I learn. That worked. There we go. So if we go to, we'll be in target, debug, target. Come on now, target. Target, debug. If we run rustywolf.exe, everything prints, everything's good. All right, now, since everything builds, we know that everything should work, which is like another nice part about Rust is like, because everything's so verbose and you have to kind of like build things correctly in order for it to compile, you can have like relative faith that it's in fact going to work correctly. But since we haven't actually like implemented any of these functions yet, you know, right now we don't necessarily have anything to work. All right. So let's see, what do we got next? Let's see. So we've got a couple of scaffolding functions here. Let's see if our C2 stuff is done. All right, we finally have VS Code working. So let's pop over to VS Code and start writing some C2 code. So we've got API.py. What we're going to do is import JSON requests fast to from fast API, import fast API, and from fast API dot middleware dot cores import I think it's cores middleware. So we will do app equals fast API and app dot add middleware cores middleware, and we'll do allow methods and most importantly allow origins. Writing some super insecure code here, and then app.get hello world def hello world return status success and message world. All right, so let's pop open an integrated terminal, and we're going to do unicorn API app. Ah, shit. All right, so we have to actually install it, and that better not take as long. Go a lot faster if I could remember my password. It's 1.6 megs. That should be pretty quick, and it is. Now let's give it a try. That didn't work. The UV loop greater than or equal to. That's not an error I've seen before. I don't need to worry about that. Version conflict. Huh. That's not an error I've ever gotten before. Requirement parse. Let's see. Unicorn version conflict. Fast API unicorn version conflict. Let's see what that issue is. I've never had that one before. That's weird. All right, let's see if that works. Python 3 -m. Unicorn main app reload. The module named WebSockets.DataStructures. What is missing here? I mean, is it on or nah? No, it's definitely not on. A module named WebSockets.DataStructures. This is a weird one. I've never run into any issues with Fast API literally until I live stream. Is it just like a module that I didn't install? But I should have installed WebSocket. That's weird. Says it's already satisfied. Let's bounce the terminal. I'll actually open up this terminal, Uvicorn app, and that's API app. Huh. This is so weird. It didn't install any of the dependency for Uvicorn, apparently. Well, now it is. Pip 3, uninstall Uvicorn. Pip 3, install Uvicorn. All right. There we go. All right. Progress. I don't know what happened there. That's weird. So now we should have localhost 8000 / hello world. Yep, we do. Apparently I managed to open up 2 windows, question mark. Exit out of these. Right. Okay, so we've successfully got it running. So now what we need to do is app.post add vic def add vic, and we are going to have a vic type victim. Return empty that. App.post, let's just do app.get vic def get vic, and we're gonna have an ID which is of type str. Let's see what else we need. A data directory is going to be here. So let's go ahead and create that. Data. Let's see, what else do we need? We need app.get ping def ping. Turn that. All right, so what we're going to be doing with this, obviously it is a C2 like web app API type thing. Works just like any other REST API. There's not really anything different. That's one of the reasons why I enjoy it. What we're going to be doing here is this is just going to be generic CRUD stuff, and we're going to be doing all of it to a victims.json file. Right, and this victims.json file is going to have all of the victim information that is basically structured in a certain way, and because Fast API uses strict typing, or it can use strict typing, then we can define that, and we need to from Pydantic, import base model. Yeah, I think we need to install that. Let's see. Put 3, install Pydantic. All right, we're good there. So class victim is going to inherit from base model. Our victim is going to have an IP, which is of type string. It is going to have, let's see, what else is it going to have? A last ping, which is of type string. And it's going to have an ID, which is of type string. Let's do first ping as well. First ping type string. So when we add the victim, that is going to be all of the information that we get within our post. And if I didn't think it was going to take forever, I would go ahead and install something like Postman. But we can also use curl, I guess. Don't really want to mess with curl right now, but just kind of take my word for it. Basically what this is going to do is we're going to send a post request with all of the specific information in it to the advic endpoint. And it is going to add the victim to the victims.json. Very simple stuff. So let's go ahead and create a helper function here. What am I doing? So we're going to do getFix, def getFix. And that's going to be with open data dir plus victims.json read return as f. Let's see, as f return json.loads f.read. Then def. What sort of data is stored in a CVE list? What? What do you mean by that, Pinquin? A CVE list or a CVS or postfix? This is going to take Vix, which is of type, I think you could do a, no, it's list of victim. Can you do it that way? I don't think you can. Let's not worry about that. Then for Vic and Vix, no, we don't have to do that either. Let's just do with open data dir plus victims.json. Right, we've got a typo here. Ooh, that should be read. That is F. Let's do f.write json.dumps fix. And don't need a return there. So what do you mean by what sort of data is stored in the CVE list? That's vague, and I don't really understand it. I guess you probably popped off. CVE list could be literally anything. I'm assuming he meant comma separated value like CSV, but I'm not 100% sure. Okay. So we've got our helper functions there. So what we need to do here is JS equals getFix. And then we do JS dot, let's see, so it's going to be a list JS at victims dot push. I have an online class for cybersecurity and I'm trying to find the answer. Oh, so you're asking for like homework question help. You're at least going to need to be a little bit more like you're going to need to explain what you mean by a CVE list, like a list of CVEs, because you could just look up, I don't know why I'm doing your homework for you. Let's see, CVE, cve.miter.org. Let's see, find all kinds of cool information. It's most recent, SSL, CVE. I don't really follow CVEs very much, but yeah, so it's like a generic CVE. What is the question? I'm not understanding what the question is here. Because this is, I mean, there's lots of information in CVE lists. Depends on what your source is. So that's MITRE's CVEs. You know, kind of depends. Yeah, I would look up what CVEs are and start kind of like understanding that, and like what you would get with the general like report for a vulnerability. That's gonna be what helps you. Right. Let's pop back over. Push. Let's see. Vic.toDict. We'll need to create that function. Def to dict. Self. Return. Self dot. So let's do IP. Self.ip. Last ping. Self.last ping. First ping. Self.first ping. ID. Self.id. Alright, so there's our toDict function there. That's pushing to it, and we will return. Let's do postfix JS. Then we will return JS. Status. Success. We'll do error handling here in a second. Fix. JS. Victims. Right, so basically what this one's going to do is we will send it this, basically a JSON blob with this specific information in it. It will throw that into our victims .json list, and then it will return back the actual list of victims there. Seems fairly straightforward. Here, we're basically going to do the opposite. Get vix found equals false for vic and JS victims if vic ID is equal to ID, return status success, if I can write, victim vic. And if it doesn't find it, so we can actually get rid of this line. If it doesn't find it, we're going to do status failure message victim with ID not found. Format with ID in it. Cool. So basically what this is going to do is you will send an ID for a specific victim. It will search through that library and or that JSON file, and if it doesn't find the victim with that ID, then it's just going to send you back a generic error message. If it does find it, then it will return all of the data for that specific victim. Cool. Cool. Identify an example of the sort data that is stored in a CVE list. Yeah, I mean, you're gonna have to do that. I'm not really understanding exactly what your homework's asking for, and I don't really want to make a stream about doing your homework. Good luck to you though. Sounds fun. So ping. This is going to return status, success, message, Pong. So we've got our very, very simple API here. Let's make sure that was actually debugging. It's not. What? Apparently I'm just not doing equal signs now? Question mark. Cool. So we should be able to hit the ping. So let's try ping. That worked. And we should be able to do get vec id equals eat internal server error. So that wasn't supposed to happen. Key error victim. Oh, so I haven't actually added a victims. We'd make that empty. Now let's try. Cool. All right, so that works the way it should, even though it doesn't work because we don't actually have any victims yet. So let's go back to our notes. We've got a simple API. That's done. Simple JSON format. We're gonna call that done because we technically have that, and a very simple dashboard. All right, so this is going to be very simple because my voice is going out right now, so it's gonna have to stay simple. All right, so let's go back to our C2, and we're going to build out the simplest possible React dashboard. So let's exit out of our backend. We don't need to worry about that right now. And let's close down our API. City front end. Actually, we're going to remove front end. We're going to do an npm. Oh no, do we have npm? Oh shit, it's going to be annoying if we don't. We don't. All right, this might turn into a talk show because this could take a long time. It could take a long time if I can't remember my password again. Oh yeah, it's 84 megs. All right, so we're gonna switch to just chatting now. Oh well, no, this is going a little bit faster than I expected. I wonder why VS Code took forever. Yeah, so this is going kind of slow. So basically what we're going to do here, fairly simple. We're going to create a very, very simple React application that we're going to use as the front end for our malware dashboard, or malware C2 dashboard to be exact. So as soon as that's done downloading, I'll show you what I'm talking about. So this is downloading NPM. For those who aren't familiar, that is the Node package manager. It's what you actually use to handle all of your Node.js packages. So we're going to do npm ig create React app. So this is installing the Node package create React app, which is like the easiest way to go ahead and get started with a very simple React app. So npx create React app C2 front end. What? How do I already have? Apparently I already have a bad version of npm. Sudo apt get uninstall npm. remove. Let's see. Ubuntu install npm latest. Figured this would be easy, but apparently not. Okay, we can just use nvm. I don't have curl. What the? Sudo apt install curl. How do I not have curl on here? What the hell? That's weird. Oh man, stream's dead. That sucks. All right. Okay, apparently that didn't work. Oh wait, maybe it did. I may just have to... There we go. All right, so we've got nvm installed. Nvm install. Just do that. Would be the easiest. Version latest. Nvm ls remote. Nvm install 18.12.1. There. Golly. So now we should have npm installed. Hopefully. npm, just do node version, npm version, ig. All right, so home. C2 front end. Need to install the following packages. All right, so now we're actually cooking. Progress is being made. Slowly, apparently. Slowly but surely. That is one thing about npm, is it can be fairly slow. And JavaScript packages can be unbelievably bulky. I do need to create a snapshot of this too. I don't have to keep redoing this shit, because that would get annoying for everybody involved. Here we go. All right. So what we should get, npm start. Ideally, we get the default React app. Maybe. Possibly. Golden. All right. So now we need to completely destroy that. Trust everybody, come on. So basically you need to get rid of this, that, and that. Don't need any of that. All right, so in our index.js, we can get rid of this. Anything with CSS on it, get rid of it, get rid of it. Should be good there. App.js, don't need the logo, and don't need the CSS. Forgot to use TypeScript for this, but I guess it doesn't matter all that much. I would normally use TypeScript for just about everything, but we ain't gotta worry about it. And let's cd to our C2 front end, npm start, is it npm debug? Let's see, cat package dot build, test, and inject. I think we just do start and it listens automatically. npm starts. What? npm not found. Oh, it probably, yeah, it's probably an old terminal. So npm start. Yeah, it hadn't caught up. There we go. Now we should have a very ugly front page. Yep, we do. So, a couple things we need to do now. First off, let's start using our states. Const backend. We don't really need to put this in state, actually. Const backend equals 120. Let's just do localhost on port 8000. Since we're mainly going to be making HTTP calls to this, we can do that. And let's put a trailing slash. Why not? All right, so there's our backend. We're going to create a couple of components here. Let's do const alive set alive equal to react.use state, and we're just going to use dead first, and we're going to do react.use effect alive, and this is going to be a function that. All right, so we've got an async function within this function. Async function, let's just do async getter. Function getter, there we go. And we also need to install Axios, but we'll get to that. Let's see. Let ping equal to axios.get backends plus And this is going to be ping. I think it's ping or get ping, one of the two. Need to await that. And then let res equal to ping dot await. Well, that actually should be, say, ping at data. I think it should be dot data message, maybe. We'll have to test that out. Return res. Res, say let res equal to getter. That's not gonna work. Let's see. How are you supposed to do that? I've done this 1,000 times and I always get it wrong. Async functions within use effect. Okay, so I'm doing it right. All right, if res is equal to pong, then set live to live. Else set live, set alive is already dead, so we don't need to reset that. So now this is already a watcher on alive. Actually, let's just do this. So that's going to run as soon as the page mounts. This is going to run if alive is ever changed. So if live equals to alive, then set render to p backend is alive at backend. Else set render to p backend is dead. And here we are going to render it. We need to actually create render. And we're going to instantiate it to be empty tags. Cool. Actually, let's put loading. Right. So this is actually going to need to be done within a try catch. We're just going to return null here. Because if the server is dead, then this is going to throw an error because it's going to try to access this within an object that doesn't exist. So let's see if that is compiling correctly. It is not because we haven't installed npm I Axios. Once that's installed, we should be good to go. Need to bounce that. Should get loading here at the top at first. Oh, we might be getting a compile error. Yep, we did. Axios isn't defined. What? I mean Axios isn't defined. I fucking installed it. npm install Axios. Start. I don't know why that didn't work. There we go. Alright, backend's dead. So let's start the backend. Colon API app. Backend started, it's on 8,000. Should be what it's supposed to be. So we try it. Backend's still dead. It's interesting. Ooh, something's angry in the console. Ooh, something's very angry in the console. Oh, I didn't actually import Axios. That would help, certainly. Let's give that another shot. Now that Axios is actually there. Uncaught. Promise cannot be resolved with itself. What? Line 21. So this we can throw in here. Alright, so we've got no more errors now. P cannot be descendant of a P. That shouldn't be a real problem. So is it reaching out? It is. So it's hitting ping. Vetting. Res. Let's just do console.log outside of getter res. Let's see what res actually is. Yep. So we need to await it somehow. So this is the fun part. Within useEffects, and what useEffect is basically it's a way of monitoring for state changes. And within this one right here, so the second parameter is a list of pieces of state that you're looking for to change so that you can run whatever code is in here. So if we look at this one right here, we are basically waiting for the state of alive to change. And once that happens, then this is going to run. It's going to change what's rendered. So right here, since we have an empty array, this is basically saying only run this as soon as the page is mounted. So the second that we establish any sort of state, run this. And it won't ever run again. You can change the state as many times as you want. This will only run once. So, problem being is you cannot directly call asynchronous functions within useEffect because you're going to get basically endless calls within useEffect. So you basically have to define the asynchronous function here and then call it synchronously. Well, because the asynchronous function returns a promise, and we can't necessarily handle that with an await, for example, because that's not allowed, since this is all supposed to be synchronous, we're basically just like stuck. Could do this, I think. Res. And then, yeah, you call getter. So we could technically just do all of this within, yeah, let's just do that. We can do all of this within the asynchronous function. So just gonna await that. Can do this here, set alive there. We no longer have to do this. So basically what this is gonna do is it's gonna call the asynchronous function and it's just gonna all run synchronously, which is like a really dumb workaround, but it's just gonna have to work. Yeah, so now we've got a living backend. So now that we've got a living backend, we want to have a victim state. So const victims set vix equals to react.useState, and we're gonna have it start as an empty list. So what this is going to do is, as soon as the page renders for the first time, it's going to fetch the victims from the backend. So we're going to do this all within the same getter function, I think. Let vicping equal to await axios.get backends plus, and let's see what our endpoint is supposed to be because I can't remember. Let's see. Ah, crap. Am I going to have to open? Do I have a VS Code open? We'll close these out. Close that out. Close that out. We just need one of these open. And we're actually going to need another window. We'll open up our backend code and let's see. C2, backend. We'll just open that whole folder. We're doing so we've got to get Vic. Let's just do a generic app.get vix def get vix gs equals get vix return status success vix equals, oh my gosh, js, and I think it's victims. All right, now should be able to switch back here, do backend plus get vix. I think it's just get vix, right? Get underscore vix. Yeah, okay. Now we've got that. Try let vix equal to ping.data at victims. I think it's victims, right? fix. And we do set vix, vix. Here we don't want to return. Here we want to do console.log. Backend is dead. Catch error console.log. Was not able to successfully grab victim list. All right. So this is going to grab our initial victim list from our backend. And here we are going to actually render it. I'll show you how we're going to do that. Fairly simply. Let's get rid of this. Going to do a div. Class name equals victim list. And we're going to do a map. I think it's victims. Yeah. Victims.map. Vic. And we are going to return let's see. We're going to return, let's just make it a generic P with an ID equal to Vic ID. So each one should have an ID. And we'll do within the P Vic IP. That's how we'll do it. All right. So for right now, you're just gonna have to trust me that this works. Reason being, I'm about to hop off because it's been like a long ass 2 hours. We've made progress though. We have what will eventually be a working backend. Let's pop this open. We have done this more or less. We have done this for sure. We have not done this. We'll save that for tomorrow's stream. I guess in like 12 hours from now or something. But we made progress. So here's what we did. Pop on over to Face so you can look at me. We created some skeleton code, very, very simple skeleton code for the malware itself. And we created a very, very dead simple, API and what will eventually be a very, very simple dashboard. Next up, we need to do the actual network code on the malware side, which is going to be lots of fun. Plan on doing that tonight or tomorrow night. But until then, thank everybody for joining. Thank you for watching the VOD if you're watching that